All right, you guys, so number 31, we're looking for what the response variable is, and the first one is kind of talking more about what we're actually trying to find, the true proportion of trees that suffered more than 50% damage due to frost. B says the number of trees affected by the frost. C says the number of trees sampled from the grove. Those are not the response variable. We want to look at each sampled tree and whether it suffered more than 50% damage or at most 50% damage. So the correct answer is E. Okay, which one would we have a tough time using a census? So a census is when you sample every single thing in the population. B would be the toughest one when you have fish. In a C, it would be impossible to catch every single type of fish in the whole entire Gulf of Mexico. And so B would be an unreasonable one to do a census on. All right, you guys have to know this formula. Guaranteed it will be on there, and it's not really given to you on the exam. So this is the formula for margin of error for proportions. If you were doing means, this little piece here would change to sigma over the square root of n, okay? So we want 90% confidence. So that's how we get our Z star. We take 10% and divide by 2 for inverse norm, and our area is 0.05, and we get 1.645. Okay, we don't know any P's. If there was a sample proportion, we would use it, but we use 0.5 if they don't give us one. And then why are we plugging in 0.04? That's probably where most of you messed up. You probably plugged in 0.08. The actual width of the confidence interval is 0.08, whereas the margin of error is from the center all the way to one tail. So you have to divide by 2 to get 0.04. Okay, solve this and always, always, always round up. So don't just pick the closest answer to what you get. You want to have at least that number. So you want that number that you get or more. So pick the next biggest number if the exact number is not on there. So it's E. All right, 34, you guys. We're increasing every single thing by 50 cents. So the mean will definitely increase by 50 cents. What doesn't change is the range and the standard deviation. Remember, we never add or subtract from the range or standard deviation, because if every single thing is raised by 50 cents, that doesn't change the spread. So the correct answer is D. All right, 35, we're looking at expected counts. So this is a chi-squared test, and we want for females at the medium level here. And so we do the row total, so you got to add all those to get 120, times the column total, so add those two to get 90, divided by the total, and you get C, 54. All right, so these first three are your sentences for confidence interval. You just have to know the order that you're subtracting. So it says you're constructing a 95% confidence interval for the difference by subtracting the proportion of females from males. So because we got a negative, females exceeds males, so the correct answer is A. 37, remember your assumptions that are necessary are random, 10%, and large counts. And large counts means it tells you it's normally distributed. So the correct answer is D. These first three have nothing to do with any of the things we've ever checked, okay? Oh, and by the way, why is it not this one, E? That's because they aren't talking about matching up like their top salespeople. If they were to say we're going to take the top 2 salespeople and the next 2 salespeople, that might be a matched pairs, and we would just compute one, but we're just talking about 2 different samples, so you want to make sure both samples are normally distributed. I thought this one was a tough one. So what is the lowest number of cards the subject needs to call out correctly in order to show that he is doing better than if he were simply guessing? So if you're guessing just red or black, then the true proportion would be 0.5. That's just if you're guessing. Okay, this formula just comes for a z-score from a random sample. It's a test statistic equals the statistic minus the parameter over the standard deviation of the statistic. We don't know what this p-hat is. That's what we're trying to find, the lowest number to prove that they're doing better than just guessing. So we want a 5% level of significance, meaning this top 5% is shaded, so they're in this region, showing that they really are doing better than just guessing. So your inverse norm, if you do 0.05, you get a negative 1.645. I guess technically we should do 0.95 for the area. You always shade left. That gives you positive 1.645 for your test statistic or your z-score. And then in the denominator is your formula for standard deviation for p's. If you know the true p, you use it. So 0.5 times 0.5 over n, and they said to do 100 cards. So solve for that, and you get a p-hat of 0.5823. So out of 100 cards, you need to get at least 59 right to prove that you're doing better than just guessing. All right, the next one is B. This is definitely matched pairs. It says 25 different engine types are selected, and each one is tested using oil with additive oil and oil without the additive. So basically each engine does both things. So that would be matched pairs. And then are we talking about means or proportions? So we're talking about the lifespan of an engine. That would be means. So the correct answer is B. And number 40, for chi-square test of independence, it's rows minus 1 times columns minus 1. So if you have 3 by 4, you're going to do 2 by 3, which gives you 6 degrees of freedom for number 40. All right, so it would be good if you blocked by breed on this one. So first we're going to weigh the salmon before the experiment begins, and then we're going to use a randomized block design. So if you don't block, you would say a completely randomized design. We want to block. So randomly divide each group of salmon into 3 groups of 10 salmon each, and place each group into separate tanks. Feed 1 tank of each breed one of the 3 types of food. So you have 10 sockeye eating food A, and 10 sockeye eating food B, and 10 sockeye eating food C. Likewise, there are 10 Chinook eating each type of food as well. So you'll do the same thing with the other type of fish. After 10 weeks, have the evaluators weigh each salmon in each of the 6 tanks and report the results. Okay, you can actually say single blind or double blind on this one as long as you explain what you mean. So single blind would just be to make sure the evaluators don't know which type of food each salmon ate. I suppose the salmon know what kind of food they ate if you say single blind. Double blind, you could just say the salmon, it's not like they understand what type of food they're eating. So you could also explain double blind, just make sure you know what it means and you prove that you know what it means. Okay, so for this next one, we want to know if women prefer chocolate for dessert more than men out of all Americans. But they only go to one restaurant here and compare who orders dessert. So what is the problem with that, basically? The target populations are the population of American men and the population of American women. And the sampled population that we used are the population of male customers at this restaurant who order desserts and the population of female customers who order desserts. So sample populations, they're not really, in this case, representative of what the target population was. So again, we can only conclude for people like the ones in the study. So for customers of this restaurant who actually order dessert. You cannot draw conclusions for all men and women in the US. All right, so why is this test inappropriate? How come we should not do chi-square tests for independence? So the nutritionist is interested in testing a one-sided alternative. We want to know if the proportion of women is higher than the proportion of men. So chi-square test just checks for independence between sex and if they order chocolate. All right, so it would be better to use, part C asks which one, a 2-sample z-test for difference in proportions with a one-sided alternative. Normally, they would make you do one on this question, whoops, but they didn't. They just wanted you to explain. So hopefully you guys did well on this and are doing well on all your practices.